Okay, so this is 6.1, where we're going to start talking about the normal distribution and how it can be used to model and work with different data sets. So a normal distribution, it is continuous, symmetric about the mean, and it is bell-shaped of a distribution of a variable. The normal distribution curve is used to study a lot of different variables, things that we might measure that are different for different people, things like height, how long a battery is going to last, cholesterol, your IQ can be measured and modeled using a normal distribution. The normal distribution shows up in a lot of places. Now, a standard normal will look like a symmetric bell curve. You can get a positively skewed distribution or a negatively skewed distribution if there's outliers that pull the data one way or the other. But we're going to study and focus on the standard normal with standard deviations. All right, there are, the normal distribution doesn't always look identical. It depends on two characteristics or parameters. We talk about the mean and the standard deviation. Here you can see two standard normal graphs that have, or normal bell curves that have different means will have different high points, whereas they could have the same mean but different standard deviations. The standard deviation creates flatness to the curve. And obviously if they're both different, then you're going to see two totally different curves. Normal distribution, if the mean or the average is right in the middle, you get about 68% within one standard deviation, meaning you can move to the right one or to the left one. So above or below the mean, one standard deviation, you get about 68%. 95% if you go to the second standard deviation, and about 99.7 if you go out to the third standard deviation. So anytime you go past the third standard deviation, which this goes on infinitely forever, you're really talking about a very, very small portion of the population. With a z-score, which is how we take just data from a problem set and transition it to a normal distribution, we need to have the z-score, which compares it to the average based on the standard deviations. So the z-score of a number is x, the number you're focused on, minus the mean divided by our standard deviation. This is going to give us a number either negative or positive, usually between -3.5 and +3.5. You can get a z-score beyond that, but it's just extremely rare. If you want to find the area, if you want to find the probability of being less than something, we use the left side of any z-value. And so if I find a z-score, if I calculate the z-value, and it's a positive z, it'll be somewhere over here on the right, whereas a negative z will be somewhere here on the left. If I want the area on the left of that value, I'm just going to read the chart or the distribution table. Let's take a look at an example of a z-table. So here you can see we have the negatives on this side, all the z negatives, and if I go to the next page, I get all the positive z's. So let's take just a really simple example. Let's say that my z-score was 0.72. Okay, so it's 0.7, and then I look up here 0.2. Okay, if I look at where those two things meet, that means that 0.7642 is on the left of that value 0.72. Okay, so that 0.2 just puts the 2 right behind the 7. Okay, so a z-score of 0.72 means that 76.42% of the population is to the left of that value. Okay, so that's how we'd calculate the left side. We just read the chart. If I'm doing the right-hand side, there are two ways to find this value. One, look up the z-value from the table and subtract from 1. Because the area under the whole curve is equal to 1, it stands to reason that if this value from the table was 0.3, that this area to the right would be 0.7. But there's something else that's worth noting. Let's take a look real quick and make sure that we understand how to do that. Let's go back to our z-table. If I wanted the area to the right of 0.72, I would take my 7642. So if it was if z is 0.72, okay, the area to the right would equal 1 minus 0.7642, which is 0.2358. Okay, that would be the area to the right. So if I was doing a problem like this, that's that area, 0.2358. Now there's another way to find it though. That was the z of 0.72, but then I had to subtract that value from 1. If instead I just go and find the z value of negative 0.72, which is actually over here, because of the symmetry of the normal curve, this area will have the same size as this area. So if I were to go and look at that z table for negative 0.72, I'm going to come up here, negative 0.7, and then 2 is going to be, because it's 0.0, 0.1, 0.2, and there's that number, 0.2358. So one way to find the right is to take the left and minus 1 from it, or minus it from 1. The other is to just switch the sign of your z-score. If you switch the sign, it's going to produce for you the right-hand side of the original 0.2358. So again, it's the left side of the negative is the same as the right side of the positive. Now if I had done the right side of a negative z-score like this, I could have done the right-hand side here by shifting it to the positive and going back. So you can just reverse the sign, whatever it is, positive to negative or negative to positive, and that will give you the right-hand side of the curve. Sometimes we have to find the area between two values though. If we're ever asked to find the area in between two values, then what we're going to do is look those values up on our chart, and then we're going to do the right value minus the left value. If this is 0.4 and this is 0.7, okay, then the area in the middle is the part that doesn't, get used by both. So those are both 0.4 over here. This stands to reason that right here we would have 0.3. So if we just take the 0.7 minus the 0.4, always right minus left, we're going to go ahead and get the area in the middle. So some examples of this that we can use, and we'll go through this on the chart. If I want to find the left side of 2.05, I always like to draw a quick little bell curve. 0 would be right in the middle, so 2.05 is right here, and it says the left side. Well, the good news is the left side is the side that the chart gives me naturally. So I'm looking for 2.05. I'm going to come down to 2.00, 01, 02, 03, 04, 05. Right here, 0.9798, just to check. Yep, I'm under the 05. So 0.9798. And if I want to do the right of negative 1.4, there'd be 0 right in the middle. Negative 1.4 is here, and I'm looking for the right side. So rather than go find the z of negative 1.4, I'm going to go find the z of 1.4. By doing the opposite sign of my z value, I'm going to get the right-hand side. So we'll go back to our table and look for 1.4. Now it's 1.40, which means that it's just this very first value, 9192. So that would be 0.9192. Okay, so we can find these probabilities of being on one side of the line or the other. And then here we have between 0 and 2.18, which should be this middle space. So I need to find the two probabilities and subtract them. Always the right value minus the left value. So I'm looking for 2.18. 0, 1, 2, 3, 4, 5, 6, 7. I have to go over some more. 8. So 2.1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 5, 4. Okay. 0.9854 minus the probability of 0. Well, that one is 0. Or sorry, it's 50% because it's at the halfway mark. At 0, we're always at 50%. So this becomes 4854, and that's our final answer. Okay. All right. Sometimes, though, we're asked to find a z-value for a certain percentage. So, for instance, ignore those. Pretend those aren't there for the moment. If I was asked to find what z-score produces a 92.22%, that's I'm in the 92nd percentile, however you want to describe that I've got 92.22% below me. If that's what I'm looking for, then I'm going to scan the chart for that value. And so I'm going to go back to my chart, and I'm looking for a 92222. Was there a 9? Yeah, 9 and then 3 2s. So for instance, I see a 9 and then a 3, I see a 935. I want to go 920, 9222. So if that's the target that I want, what's the z-score? 1.42. Okay, and so I could say that this one would have to have a z-score of 1.42. We have to scan the chart to find them. Now here, if I want 0.6628 above it, that means I want 0.3327 below it. So I'm going to go look for that number on my chart, 3372. These are all bigger than 50, so I'm going to go to the negative side. 3372 right there, which makes it, let's see, negative 0.42. And so we could come up with the z-score for a problem like that. Negative 0.42. Okay. All right. Well, guys, that's how we do this. If you have questions, please come talk to me. In 6.2, we'll talk about some ways to use a calculator to help speed this process up a little bit. All right. Good luck, and we'll see you in class.